Lesson 5.3, Polynomials and Polynomial Functions. We have four concepts in this section that you need to be able to understand. The first is that, can you determine what type of polynomial you're working with? To be able to determine a polynomial degree. Defining function values, which you've done before, so this is a little bit of a review here, but with just different types of polynomials. And fourth, adding and subtracting polynomials, which is the biggest thing that you need to take from this lesson. So to start with the polynomial types. We have four types of polynomials. Three of them have a special name. The first one is what's called a monomial. It has one term. So like the number 4 is a monomial. It's a single term all by itself. 9x, one term all by itself. Negative 10xy squared is one term. It's a product of numbers put together, or just a plain number. That's a monomial. Okay. Second, binomial. Bi begins with bi, like your bicycle. A bicycle has two wheels. Well, binomial means two terms. So you have 4x minus 6. That is a binomial. X cubed plus 9. That's a binomial. 3xy minus 5z. That's a binomial. All of them have just two terms in it. So we call it a binomial. Now, third, of course, is going to be you guessed it, a trinomial. Tri is the prefix, meaning 3, so we have 3 terms. So one example would be like x squared minus 5x plus 8. That is an example of a trinomial. Another trinomial that I have here, negative 2x to the 4th plus 8x squared plus 5. Again, there are 3 terms in this, so it's called a trinomial. The fourth name, well, is actually just the word polynomial itself, and it has a definition to it. And a polynomial is just a sum of terms where exponents are positive, and there are no variables in the denominator of a fraction. If you look up in all of these terms up here, there are always positive exponents. If there isn't an exponent, we know that exponent to be 1. I could put a 1 right there if I'd like to. So you have all positive exponents. No variables in the denominator of a fraction. What does that mean? Well, if I have this, x over 4, I can rewrite that like this, 1/4 times x. So now I have a product of 1/4 and x. So this would be considered a monomial. When it's written x over 4, I don't have to have the 1, so we tend not to write it as 1/4. We show it as x divided by 4. But this is a monomial. The reason, if you don't have a negative exponent, just to remind you of that, if I have a term that says n to the negative 3, I'll rewrite that as 1 over n cubed, like so. Well, if I have n cubed as a denominator, the bottom of this denominator, what number could I put in for n? What causes trouble? That's right, it's 0. If I put 0 down there, now I have something that's undefined. So polynomials, we do not use something that's undefined. This is not a polynomial at all. So exponents are positive and no variables in the denominators for any polynomial. All right, so let's move beyond this. Lastly, I want you to understand that all monomials, binomials, and trinomials, they are considered polynomials. All three are lumped into one category. You have the category of polynomials. You have 3 special types: a monomial, meaning 1, binomial 2, trinomial 3. Anything else, if it has 4 terms, 5 terms, 6 terms, we just call it a polynomial. Moving on to degrees of polynomials. Degrees of polynomials help us when we're actually working more. We use them a lot when we're working with trinomials and binomials. So degrees of polynomials. So here are 5 different polynomials. To talk about their degrees, we want to look at the exponents on the variables. If I look at a plain number 5, there is no variable here with an exponent. So I would say the degree of this is 0. The reason for that is if I want to keep the values to be 5, I could say 5 times n to the 0 power. Anything to the 0 power equals 1, and 5 times 1 is 5. So I would say the degree on this is 0. I don't have to write n to the 0 power there. So anytime you have a plain number, the degree is 0. I have a monomial here, 3 times x squared. I know that the degree of 3 is 0. X squared, what is the number for the exponent? The number is 2. So since the number is 2 on that exponent for the variable, the degree is 2 of 3x squared. It's the degree of 2. I have another monomial here. I have 12 I have x cubed, I have y, that's y to the first, and z squared. So how do I determine the degree when I have more than one variable? I am going to add up, since this is a single term, I will add up the exponents that I see. 3 plus 1 plus 2, that means this term has a degree of 6. 3 plus 1 plus 2. I'm adding the exponents that I see on the variables. So that's how you can look at it with just a single term. What do we do then when I have more than one term, like in a binomial? Well, let's look at our first term. Our first term has negative 9xy cubed. The degree of this term is 4. Let's look at our second term. The degree of this term is 1. Which of those is higher, 4 or 1? Yes, 4 is higher. So when I have a binomial, trinomial, or polynomial, I will take the degree of the highest term. Last example here for degrees, I have a trinomial here, 4x squared plus 3x minus 2. The degree on the first term is 2. The degree on the second term is just the 1 there, and the degree on the third term is 0. So the highest degree possible is the 2 on the first term, so the degree of this trinomial is 2. So binomials, trinomials, if you have 4 terms, 5 terms, find the term with the highest degree. That is the degree of the whole polynomial. Moving on. Finding a function value, which you've done before. This time you'll have a trinomial where you have f of x equals x squared plus x plus 1. And you'll be told find a value such as find f of 4. So I would say that f of 4 is going to equal 4 squared plus 4 plus 1. And 4 squared is 16. 16 plus 4 is 20. 20 plus 1 is 21. Finding that. And that is a review from before. You've done that. I think you'll do just fine with that again. Last thing that we need to deal with today on this video is going to be adding and subtracting polynomials. This is the meat of the video now. So when you're asked to add and subtract polynomials, I'll start with an addition example. You may have them written this way. This is a horizontal design on an addition of a trinomial and a binomial. When we do this, the best way to do this is take a look at your polynomials and you line them up vertically. So I'll start with writing out this trinomial first. I have 4x squared y minus xy squared plus 5. I'm adding to that negative 6x squared y minus 1. Writing out my first one, I'm going to have 4x squared y minus xy squared plus 5. My second term is a binomial. What I want to do is line up the like terms. So I have a negative x squared, negative 6x squared y. I'm going to place that underneath 4x squared y because they are like terms. Minus 1. Minus 1 is a regular number. I will have nothing underneath the minus xy squared because this next, what I'm adding together has no term x y squared. But I do have a minus 1, so I'll write that over here. I'll just have that space in there. Now I'm adding these. So I have 4x squared y plus negative 6x squared y. Well, that will be a negative 2x squared y. There is nothing here to add for the middle term, so I just copy down minus x y squared. And then I have 5 plus negative 1 plus 4. And now I've added together these two polynomials, this trinomial and the binomial. So for addition, you're going to add up your like terms, one up on the other, so we'll put it in a vertical format, and then you will add together the like terms to find your final answer. Subtraction. So if I'm asked to subtract, here are two trinomials I'm asked to subtract together to one another. I start with the one term on the left, and I'm going to copy that down as 7x to the fourth. And I want to take a look now. Do I have an x to the fourth in subtraction? I do over there. Now my next term is minus 8x squared. Do I have an x squared in the other trinomial that I'm subtracting? Yes, I do. So I'll be lining those up. Here is an x. Do I have an x over here? No, I don't. And I don't have a number in the first one, but I do in the second. So I'll show you how we're lining that up. 7x to the fourth. And I'll write down minus 8x squared plus x. My next trinomial, I have a minus, and I'm going to put a parenthesis because I have to subtract the whole thing. It represents one number. Minus 9x to the fourth. I have a plus x squared. And then I have a minus 18. There's nothing for the x. Leave a space and put minus 18 over here. And close off your parenthesis. I'm going to draw a line underneath here. My mind prefers addition over subtraction. So what I'm going to do is I'm going to remember the phrase that you've been taught from a long time ago called same, change, change. So I'm going to keep the first trinomial the same. I'm going to change my subtraction to addition. Because I've done that, I have to change every term inside the parentheses. So I'm going to then, instead of a positive 9, that's going to become negative 9. Instead of a positive x squared, it's a negative x squared. Instead of a minus 18, that becomes plus 18. So now I have done same, change, and I have changed the sign on every single term inside the parentheses. Now that I've done the same change, change, I can do my addition. 7 plus negative 9, negative 2x to the fourth. Negative 8 plus negative 1 x squared, we have minus 9x squared. X plus 0 will be x. Since I have nothing above the 18, then I need to remember that that is like a plus 0 sitting there. So I then have 0 plus 18, and I have plus 18 as an answer. And at this point, I'm done. There will be no like terms to combine. So that's lesson 5.3. We have our degrees of our types of polynomials, our degrees of polynomials, and adding and subtracting them. If you need to run the video back to watch it again, feel free to do so. Your assignment for this section is as follows. Okay, let me pull that open so you can see it. It's from page 280. It's numbers 2, 3, 9, 12, 13, 16, 17, 19, 21, 33, 42, 47, 53, 56, and 61. You're more than welcome to start that now at home if you'd like. If you're watching this at home, if you're not and you're watching it in class, then please write this down in your notebook and we'll get to work on that. Thank you for watching.